Today we want to work on how we develop some of the formulas for area of different figures. We're going to only work in the two-dimensional figures. We're going to talk about area, but let's start with the ones that we're familiar with. Like, we're very familiar with rectangles. If we've got a rectangle, and we've got the base and the height, or length and width that we're familiar with, the area of that is just equal to base times height. Very familiar formula. What we want to do now is use that to develop other formulas. Like, I don't know if we've ever done area of a parallelogram before. Let's look at how that would be developed. So when we look at this, a parallelogram looks like this. We've got the parallel sides. If I draw this altitude down to this side here, what I have is a triangle that I can take and put on the other side of the parallelogram. So we're going to take this, we're going to move that over here, and if you think about that triangle going over here instead, I now have what looks like a rectangle. So if we call this side here the base, and this the height, which is an altitude, so it's a height of it, the area of a parallelogram is also equal to base times height, where this is the base of it, and then you have to go with the height being the perpendicular down to the side here for the h. So we have a very similar formula just by thinking about that triangle coming off and going on the other side gives us the same formula for base times height. Now let's apply that to triangles. We've done triangles before. Triangles are a familiar formula for us to do. So let's go ahead and take this one, and for a triangle, we're used to, on a triangle, taking a figure, and we talk about the base of it and also the height of this one. Now if you think about that, if I take this triangle and I copy it and flip it over and put it right on the other side here, so the same triangle just flipped over and put over there, so this triangle and that triangle are congruent, so they have the same area. Notice that there's two of these together equal the whole parallelogram that's been formed. Well, if I take base times height to get the whole parallelogram and then take half of it, I get just the triangle. So therefore, if we've got area, we can use that same base times height, but in this case, it's going to be half of it because of the fact that you get half of that parallelogram when you copy it and flip it over and put it with it. Let's do something similar for a formula for a trapezoid. A trapezoid, if we think about this one, okay, we got a trapezoid where we've got one side parallel to another side, and then we connect them with legs here. Okay, if we call this base 1 and this base 2 like we did before, we've talked about the two bases of a trapezoid, and then we also talk about the height of this one. So draw the altitude here, and we've got the height of it. Well, think about if we were to take this trapezoid like we did with the triangle, copy it, flip it over, and put it on this side over here. So what I got is that this side here looks like that. I now have another parallelogram when I've copied it over, only this time this was B1, but since I flipped it over, this was B1 copied over here from that side, flipped over to that one. This would be little B2 because it's been flipped over to that side. So if I look at this parallelogram, the base of this, the whole way from here all the way over to there, is B1 plus B2. So both bases added together, I still have the height of it. So the area of this, since that's twice as big of the area that we want only one of them, the area of this one is going to be equal to half of adding the bases, B1 plus B2, and multiplying by the height. Okay, so we've got the bases added. So another way to write this that we often use, we might just say B1 plus B2 times h divided by 2. Just like the area of a triangle, we might say base times height divided by 2 for the area. So that gives us these figures all kind of combined together. They all are based on their formulas on this base times height idea, and this is how we develop those. Now, let's go ahead and talk about how we do a rhombus. Now again, if you need to take some notes, go ahead and pause the video. You can take some notes before we move on. First of all, a diagram of what a rhombus looks like. Remember, a rhombus is where you've got the four sides are congruent. And we also have that when we draw the diagonals of them, they bisect each other. So if I just focus on this triangle up here, what I have is that this height, which is what we want to have, that height is half of a diagonal, so I'll call diagonal 2, whereas this whole diagonal here, I'll call this diagonal 1. So the area of that triangle in yellow is going to be area equals 1/2 times the base, which is D1, times the height, which is half of that other diagonal. So the area of one of these triangles in yellow is going to equal 1/4 times the two diagonals. Well, if we take that formula, notice there's two triangles that are congruent to each other. If we just multiply that by 2, what we get is the area of the entire rhombus is going to equal double this, which is going to be half of the diagonals multiplied together. So that's where that formula comes from. So what we get is area equals 1/2 times the diagonal 1 times diagonal 2's length for the area of a rhombus. Now let's talk about the area of a kite. Let's go ahead and determine what that is. Area of a kite, we're going to have the exact same type of diagram for it, and it's going to be exactly the same. So if we look at this formula, the formula for the area of a kite also equals 1/2 times the diagonals. Notice that if you look at these two formulas, they are the same. So if you want to find the area of a rhombus or the area of a kite, you use the exact same formula of taking half of the diagonals multiplied together. Now let's do some examples. We're going to find the perimeter here. So perimeter and area, so we'll do both. So if you want the perimeter, you're going to take, and what I'd like you to do is think about what you would do to find perimeter and area. Maybe even if you want to pause, or you could keep going and just see how I do it, but you could pause, try the problem, see what you get for the perimeter, and then check it out when I do it. Okay, let me show you how I would do it though. The perimeter will equal all the sides multiplied or added together. So I'm going to add these. And so when I add all of those together, I have x plus x plus x plus x is 4x. And then 2 minus 1 plus 2 minus 1 is going to give us a plus 2 when I add those together. Now for the area, on the other hand, area is where you multiply them together. So I'm going to take x plus 2 times x minus 1. Now a little bit of algebra review. When we do this multiplication, we do the double distributive, which means I'm going to multiply x times both terms. And so I get x times x is x squared. And then I'm going to do x times negative 1 is negative x. Now let's distribute the other ones together. So I'm going to do 2 times x and 2 times negative 1. So 2 times x is 2x. And then 2 times negative 1 is negative 2. That simplifies to x squared plus 1x minus 2. Now, let's take a look at number 14 off of page 682 to 683. If we want to find the area, this is just based on our different sides. And so what we have to do for this one is we have to figure out what the different values are. Now I've got right triangles here, so what I want to do is I want to find this little guy here, I'll call this x, and then I need to find this side here, I'll call it y, and we can do that by using the Pythagorean theorem. And then we'll just add them together to get what the whole base is, and then we'll take base times height divided by 2 to get the area. So first of all, to get this first one here, I'm going to go 15 squared plus x squared equals 17 squared. And if I were to solve that, do 17 squared, subtract 15 squared, and take the square root to get x, I get x equal to, in this case, 8. Okay? And then for this other one, I'm going to do the same thing. I'm going to go change colors here. I'm going to go 15 squared plus y squared equals that 25 squared for that one. And when we do that, we're going to get that value. We'll take 25 squared, subtract 15 squared, and take the square root. We get y here equal to, in this case, 20. And so this whole base here, from here to here, is going to be 28 units wide. So if I want to do the area of this, it's going to be multiply the height, 15, times the base, 28, and then I'll divide that by 2, just like we do base times height divided by 2, and I get 210, and that's square inches for the answer. All right, so let's do this last one down here. Okay, doing some examples. The perimeter of an isosceles trapezoid is 40 feet. The bases of the trapezoid are 11 feet, 19 feet. Find the area of the trapezoid. So let's go ahead and set up our diagram here. It's isosceles, so my two legs are going to be the same length. So this is congruent to this. And so what I get is that it says that the whole perimeter is 40 feet, but one base is 11 and one is 19. So what we have to do is find out how long those legs are, and also we have to, that will help us find out what the height is. So if these are the same, I'm going to call each of these x. So 2x, because I've got two sides there, plus 11, plus the 19 is going to equal my perimeter, which is 40. So I get 2x plus 30 equals 40. So 2x, if I subtract 30 from both sides, equals 10. And then I divide by 2, I get x equal to 5. So I'm going to put that x equals 5 right here on my triangle, or this leg of the isosceles trapezoid. But I'm going to make it into a triangle by dropping down here the height, because I need to know what that h is in my formula for the area of a trapezoid. So what I'm going to do here is I'm going to take this, I'm going to use the fact that if I look at these, if I draw that triangle over that, this would be 11. Since this whole width is 19 and this is 11, that leaves 8 left over to be split between these two. So this would have to be 4, and this would have to be 4 to give me 4 plus 11 plus 4 gives me the whole 19. So by dropping down those perpendiculars, I can use that this is a rectangle in the middle. I can get each of those sides of those triangles. Now let's go ahead and calculate what h is. Now we can use the Pythagorean theorem, or you might remember that we could use the 3, 4, 5 triangle. So whichever one you remember, let's do Pythagorean theorem. H squared plus 4 squared is going to equal 5 squared for the Pythagorean theorem on this right triangle. I'll just color that in yellow. So that's what I'm using. When I calculate that, take 5 squared is 25. So h squared plus 16 is 4 squared equals 25, 5 squared. Subtract 16 from both sides, you get equal to 9. So h equals 3. We don't worry about the negative 3 in the plus or minus because of the fact that it's a side here. All right, so now we can find the area of the trapezoid because we have the height. I'll just put that in here. Height is equal to 3. We've got our base is 19 and our other base is 11. So our formula for the area of a trapezoid is going to be, remember, it's half the sum of the bases, b1 plus b2, times the height, which is, in this case, 3. So I get 1/2 of 11 plus 19 times 3. If I do that on my calculator, I get 45 square feet for my answer. So there's our formulas for all these different ones and how to figure out some different problems.